So our first presenter today is going to be Actasys. Actasys focuses on the development and commercialization of groundbreaking technology coming from the aerospace industry to improve the aerodynamic performance of ground vehicles.
Well, good morning, everybody. I just wanted to thank you for having the opportunity to be here today. It's been extremely exciting to learn about all the challenges and opportunities within the industry. It's really something that is going to evolve in very interesting scenarios and opportunities. So I just want to start by introducing the company and tell you a little bit of what we've been doing in the past and what our plan for the futures are. Probably a lot of you know already about this data, but one of the major problems in the transportation industry is fuel costs, right? More than half of the fuel consumed by vehicles is consumed because of aerodynamics, or the terrible aerodynamics of the vehicle, I should say, of tractor trailers. A typical tractor trailer, typical long-haul truck consumes more than $4,000 a year, and by doing that, it also produces more than 168 metric tons of carbon dioxide equivalent. So it's a lot of pollution coming off of each one of these vehicles. And if you look at it from an operation point of view, the typical fleet, the typical company, typical fleet operator, more than 20% of their operating costs come from fuel, and they're directly correlated to the aerodynamic performance of their vehicle. So the problem that we started to analyze in the beginning was like, okay, what can we do to improve this? We can change the shape of the vehicle, right? That's what you typically do to change the aerodynamics. And the problem is that in this industry, it's very tough to do that. They tried to do that in the past, but the whole industry is based on this very terrible shape, on this brickly shape, right? And it's really tough to change it. They tried, they did marginal changes, but nothing that changed a heck of a lot. So we said, okay, what can we do? The challenge is changing the aerodynamic performance without changing the shape. And we were extremely lucky to have this very simple but very efficient product or core technology. It was developed for the aerospace industry, for airplanes, and what it does is it uses very small amount of energy to produce very powerful jets of air. So literally it's an extremely compact compressor with an energy efficiency that is almost 1 order of magnitude higher than your typical compressor. So it's extremely efficient. So what do you do with this? Well, if you put these in key locations in a tractor trailer, and one of the key locations is the gap between the tractor and the trailer, you can streamline the incoming airflow. So the incoming airflow that would try to get in between the gap, get in between the tractor and the trailer, generating turbulence, you can use these actuators to produce jet of air that create a curtain of air connecting the tractor to the trailer. So the incoming airflow, rather than getting infiltrating in between the tractor and the trailer, would just continue and flow. Now by doing that, we proved that we can increase the aerodynamic performance by 20%, which translates in about 10% increase in fuel efficiency. Now, the beauty of the system is that it's smart and dynamic, meaning that we connect to a database of a weather condition. We have onboard sensors with which we can detect local weather conditions, including crosswind. And we can adapt our system to maintain optimal aerodynamic condition based on the local weather that we can detect. And we get any kind of data to operate our system, including acceleration of the vehicle, velocity of the vehicle, geolocation. We know where the vehicle is. We know the crosswind acting on the vehicle, temperature, and so forth. So we take all this data and feed it to the control system of our system, of our active flow control system, and improve the aerodynamic performance. We tested this with local fleets. We proved that we can get the energy efficiency that I mentioned. So it comes to about $4,000 saved per truck per year for the transportation industry, and we're planning to start extended trials as early as the beginning of next year, and to commercialize at larger technology towards the end of the year. Now, this was what we started with. This was the hardware solution for our company. Now, when we look at what I showed before, when we look at the system, you see that we have a cloud database, because what we do, we stream all this data from the truck to a cloud database. And we said to ourselves, how can we monetize this huge amount of data that we have? And the idea we came up with was to use this data together with databases related to weather conditions, external databases, to analyze routes from an aerodynamic point of view. And this is something that nobody is doing right now. And it's extremely important because, again, aerodynamics is key. It's 50% of the fuel consumed on trucks comes from aerodynamics. So we said to ourselves, okay, how can we do this? And the way we did it is very simple. We came out with this tool, the Aero Route, where if you're a fleet operator and you want to go from point A to point B, and you have, say, 4 different routes that you can pick that are the same length, same traffic, same tolls, what we do is we look at the weather, the forecasted weather condition along this route. We determine the wind direction and intensity along the route, a specific time defined by the user, and we determine the aerodynamic impact on the different routes. And we can literally go down to a dollar value that we can tell to the trucker or to the fleet in order to optimize the route planning. So we can tell them, hey, if you're picking route 1, you're saving $20. If you're picking route 2, we're spending $30 more than your average. Clearly, this is a route planning tool, but we also have a real-time component where we can notify the user for hazardous weather condition along the path that is planned. So we can also do that through the data we collect also in the territory. We perform a use case study. This is a local fleet. They typically send a lot of their products in the route between Schenectady and Scranton, so it's a fairly small route. And if you look at it, it's basically the same length, and from a traffic and toll point of view, it's basically the same cost. When we analyzed this, we looked at the data and we proved that on an average, every year, we can save, using this tool, approximately $19 per truck per trip, right? So that means that if you extend this to a typical fleet, medium fleet of about 200, 250 vehicles, you can save in excess of $1.5 million. Imagine how this could scale with fleets that are the size of Walmart or the size of Pepsi, where they have thousands of vehicles. So it scales very rapidly, right? It's extremely, the savings are extremely high. You're looking with this amount of savings of about 15% savings in fuel for your typical fleet. So what do we want to do now? We created this tool, but the intention is really to partner with existing companies that are already established within the industry and within the analytics, logistics analytics. So we want to customize this tool to be working basically as an additional layer of optimization and complexity on existing tools that are already taking into account of, for example, traffic condition and tolls and length. So we want to build on top of the complexity that already exists. We're planning also to deploy these to a group of fleet that have already been identified. And in the end, we really want to find commercialization partner that will take this tool and commercialize it, add it to their solution and commercialize it, because it's not exactly the focus of the company, which is more on the hardware side. For the future, and it's very interesting because I saw that a lot of you talk about this, clearly we want to get into the autonomous vehicle market. There is a lot of value into this. And as I mentioned, we have an hardware component. Imagine having this hardware component mounted on big fleets throughout the United States. We already have sensors mounted on them. So we will be able to gather all this information, create a network where we can basically repurpose this information and customize it for different customers and resell it. So sell the data. That's pretty much it. Thank you so much for Are we taking question now? Or?
Yep. So after each presenter, we'll have about 5 minutes for a question and answer session. So anybody who has any questions, feel free to ask.
Doctor, you said you were doing that case study. You may have said it, but how long was the trial period?
So, okay, good question. It was basically throughout the year. So we extrapolated the data for a year. We didn't do it throughout the year in operations, but it was a projection based on projection that we did for the year. So it was a real route for a real customer that had the real problem. We used real forecast data, and we basically did a projection for the year. So that's the way we did it. And we have more case study also in different routes and different lengths. This was particularly interesting because it was local and with a local company. Yes.
Question. Nathan Green from True Weather Solutions. Thank you, Doctor. It was very informative. But my question is, obviously, you have limited this to wind impacts and related it to a cost factor, which is very good in relaying that to the customer. But in your methodology, did you consider other factors that might affect fuel economy, which is the cost, for example, terrain, traffic impacts, speed. Anyone that's driven to Scranton knows, you might, those might affect cost and might mitigate some of the wind
Upside or
only
down, yeah,
effects.
absolutely. No, so that's an extremely good question, and that's exactly why we do want to partner with companies and logistics companies that already have these capabilities, because the way I want you to see these is an additional layer or an additional parameter that you want to use for optimizing your route. And that's why we're looking for partnership, because we don't have that component. We have this component. This component, you require a very good knowledge of how to model the drag coefficient of different kind of vehicle, make and model, and how that changes with the crosswind, because that will change. So you have several parameters that will impact the drag coefficient, and that's basically where our know-how comes in. Once you couple that with the knowledge of the directional intensity of the wind in every point of the route, you can come to the cost related to the wind. But then you have to combine it, precisely as you
And
said.
obviously, as our standard line, better sensing will drive you.
Absolutely,
So
absolutely.
that's a key component, I imagine.
Yeah, absolutely. And as a matter of fact, one of the studies that we wanted to do now with the University of Albany is to determine how the precision of the database and data set that we're using as an input to the model will affect the dollar value and the resolution of the output of our model. So, absolutely. Yeah.
I might have missed this, but, so what's the break even? So if I've got, an
For the
average
hardware?
truck and I buy
Yep.
your,
So-
how long before I break even?
For the hardware is 1 year, which is very aggressive for the industry. You're looking typically, any competitor is 1.5 to 2 years. Your typical life for a truck is 3 to 7 years, depending on operations. So if you're doing very long hauling, typically it's 3 years, and that can go down to 7 years if you have more regional, local delivery.
My question, I'm not sure, maybe you answered it. So my question is, if I buy your device, you're saying the break even is in 1 year?
1 year, and then the rest
So then
is
the next 2
$4,000
years
that
is-
you're saving on every truck, every year. Yep. Any more questions? Yeah.
What's been the response from industry leaders within the trucking industry? I would imagine that there's been a lot of enthusiasm for this.
They're very stubborn, actually. They're very stubborn. So one of the things that helped us is that we are tractor mounted now. It's much easier to target tractor manufacturers rather than trailer, because it's much more fragmented, the market. It took a while to convince them, because it's a very strange technology for the market. It's really, you can't touch it, you can't see it. It's not a surface that you're putting there and everybody understands it, right? You put a skirt on a trailer, yes, it's gonna make aerodynamics better. You're putting these things that you don't even know what the heck they do. It's tougher to make them understand how it changes. But then they saw the technology, they saw the impact. We now have a very good group of fleets that could attest that the technology works, and that definitely helped to drive the discussion with the industry.
Yeah.
Yeah.
Great.
Thank you.
Thank you so much.